If you talked to a chemist, you've heard about the mole. So we're going to come to this concept of what is a mole and why does that help us. All right, the mole concept for atoms and molecules. Take your calculators out and your periodic tables. You're going to see how what you've learned in chapters 2 and 3 about naming compounds and writing formulas, how critical that will be here in chapter 4, because we're going to pick up on the formulas and see how we use those to get in conjunction with the mole. All right, I make a big deal out of it, but in very, very simple terms, the mole is a number. Just like all right, the mole is a word that stands for a number. Just like the dozen is a word we use to stand for a number. We talk about a pair of shoes. Words that we actually use in the place of a number. Well, that's what the mole is. The mole is a number of things. Here it says a mole of atoms. It can be a mole of anything. It could be a mole of donuts. It could be a mole of anything. Anything, a mole of anything is 6.022 times 10 to the 23rd of those things. So if we talk about atoms, then we're talking about a mole of atoms would be 6.022 times 10 to the 23rd atoms. A mole of molecules would be that many molecules. A mole of ions would be that many ions. It's the same number of things. And that number is important because these atoms react with each other not according to their weight, but according to small whole number ratios. All right, hydrogen, 2 of those react with 1 oxygen to form water. Has nothing to do with their weight. It's not a certain number of grams of hydrogen, like 2 grams of hydrogen that reacts with 1 gram of oxygen. It's 2 hydrogen atoms react with 1 oxygen atom to form 1 H2O molecule. All right, so chemists are interested in the numbers of atoms that are involved in something, not particularly the weight, because they're reacting according to their numbers. All right, and why such a big number? Such a big number because atoms and molecules are such tiny things. I can't go over in the lab here and weigh out even 1 million oxygen atoms. This is not enough. They don't weigh enough to even start tipping the balance at all. Not even 1 billion, not even 1 trillion. I can't go across the hall and weigh out 1 trillion of oxygen atoms. We got analytical balances that go to 0.0001 grams. Well, even 1 trillion oxygen atoms aren't going to even register on those balances over there. 1 trillion. What's 1 trillion? What is that? That's thousands, millions, billions, trillions. So this number is bigger than trillions. 6.022 times 10 to the 23rd. Let's get a little feel for how big this number really is. we're going to take this number and put, so we got 6.022. We're going to move the decimal point over 23 places. All right, so here's 3, 4, 5, 6, 7, 8, 9, 10. 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. All right, big number. So there's the hundreds, there's the thousands, there's the millions, there's the billions, there's the trillions, there's whatever's above trillions, there's what's ever above that, and up to there. So here's millions.